Welcome to Siren Tribble YouTube channel. I have taken an example how to draw impedance diagram and then reactance diagram from the single line diagram. So first of all, I'll tell you single line diagram. All the electrical power system components are represented in the single line with their symbol. Is called as a single line diagram. Next, there is the impedance diagram. Impedance diagram that must have impedances. All the electrical components or power system components are represented by using impedances, right? And reactance diagram, only reactance will be present by representing the that power system components is called as a reactance diagram. This is one example. Okay, I have taken this one example. This one is generating station, and next one is a transformer. Transmission lines will be there, and a distribution transformer, and this is the utilization. See, it covers overall power system, right? Generation, these two distribution, this is transmission. Okay, this part is transmission. Transmission lines will be there, and then this is a utilization, consumer side, right? This is a single line diagram of power system components. So corollary of this is this one. See, there is a power plants, thermal, solar, wind, or nuclear, or whatever. It's a generating station. Okay, so generator must be there. So just keep it in your mind. Generator is synchronous generator we are using for thermal power plant, and then nuclear or hydel power nuclear power plants we are using non-silent pole turbo generators. Okay, and hydel power plants we are using silent pole synchronous generator. That's also like turbo generator only. And next is a step up transformer for stepping up from 11 kilovolts to I think you might have got a doubt, why sir 11 kilovolts only? So Indian standard value is 11 kilovolts. Okay, see here, even though people are getting doubt, why sir 11 kilovolts, 33 kilovolts and 66 kilovolts? So 10 kilovolts, and what is the 10 percentage of this 10? So definitely 1, right? So similarly 33 kilovolts, 30, so 10 percentage of 30 is 3, so 33 kilovolts. 66, 60, 10 percentage of 60 is 6, so 66. 220, so 200, and 10 percentage extra we are generating, that is 220. Okay, likewise they have given, but there is no depth in that. Okay, that's a concept. So extra we are generating, right? So 10 percentage extra, if suppose loss will occur, something will occur, so means for to overcome the problem we have a 10% extra we are generating. So 11 kilovolts per here, again we are converting into 11 kilovolts to 33 or 66 as per the requirement, and again transmission lines will be there, transmitted from power station to here step down transformer. See here on step down transformer, here on step down transformer. In this step down transformer it converts 220 to 11 kilovolts. Okay, so these step down transformers we can find nearby your home. There is a H-pole mounted substation, so there we can 11 kilovolts to 415 volts 3 phase or 230 volts 3 phase. Next there is a consumer side, right? So let's move on to impedance diagram. I will draw. So this part 1, and this part is 1, this part is 1, this part is 1, this part is 1. Total 1, 2, 3, 4, 5 parts will be there. Okay, and impedance diagram for the previous single line diagram is this one. See here, this one is a generator. See here, impedance will be there, resistance and reactance. See here, there is a transmission lines. This one is transformer. Okay, not transmission lines. So till here transformer. This one is a generator. See here, transmission lines pi module chosen, and this one is a step down transformer. See, this one generator, and this one is transformer, transmission lines, again transformer, and these two are loads, output loads. This is the impedance diagram. In this diagram 3 phase into single phase we need to convert, single phase, and then transmission lines pi module or T module will be there. Transformer equivalent circuit is this one, and load its impedance, this one is load, right? See, equivalent circuit of generator, equivalent circuit of transformer, equivalent circuit of transmission lines, equivalent circuit of step down transformer or distribution transformer, equivalent circuit of this loads, right? Next we'll move on to reactance diagram. Okay, reactance diagram, neutral reactance are neglected, first one, and shunt branches of all the equivalent circuit must be neglected, and the resistance are neglected, all static loads are neglected, and capacitance of transmission lines also neglected. See here, by reading the title itself, we can say only reactance is present. All those things will be eliminated, right? Reactance is present. This one is generator, right? This one is transformer, right? This one is transmission lines, right? This one is transformer again, and this one is loads. See, all the resistance are eliminated. Only the reactance part will be there in the circuit diagram. This is the reactance diagram explanation. You can write in your own also. See, based on the reactance diagram, we have to assume resistance must be neglected, and then all the transmission lines, shunt branches must be neglected, because that shunt branches will be there, right? That is negligible. I mean, less value will get it. So that's why we are neglecting, right? So this is the concept we are going to use in the future for solving the problems. These concepts are common for all the modules. If you know how to draw single line diagram to reactance diagram and impedance diagram, but reactance diagram is very important. So definitely you'll I'm sure 50% knowledge you gained. So concentrate on this and read.